Hello, and thank you for coming along for another of my rambles. Well, and if this is your first ramble with me, welcome. We are rambling about IEB May 2025 paper 2, question 12. Let's do it. The diagram shows circle center C. Here's our center C, our circle, with equation x squared plus y squared plus 6x minus 4y is equal to 12. Okay, so it's not in standard form. But if we get it into standard form, then that will give us the coordinates of C, the center of the circle, and it will also tell us the length of the radius, right? So something to just bear in mind. A and B are the y-intercepts of the circle. Cool. AD is a tangent to the circle at A, and its x-intercept is D. Okay, so D is on the x-axis. Then we are asked, determine the size of theta, the angle the tangent makes with the y-axis. So what immediately comes to mind for me is the fact that we have a tangent, and we could potentially figure out the gradient of this radius CA, because like we said, the coordinates of C are hidden in here, and to find the coordinates of A and B, the y-intercepts, we would just have to make x 0 in this equation and figure out the y's. So that would allow us to work out the gradient of AC, and using tan rad, we know that these two are perpendicular, so then that would give me the gradient of AD, and then that would maybe tell me angle of inclination, right, if I have that gradient, and maybe somehow I can work my way to this angle. If I have this angle, for example, then I have this angle because angles on a straight line. This is a 90 because x and y axes are perpendicular, and then this would be the exterior angle of a triangle, right? These two added together would give me this. So yeah, that's how I could use the gradient of this tangent to work my way to this guy, I reckon. So that is my plan. One weakness of mine is that once I kind of figure out one plan, it's very difficult for me to see another way to do things. So it'll be interesting to see if the memo has a different approaches that the memo suggests for the question. But anyway, let us begin. So we have the equation x squared plus y squared plus 6x minus 4y is equal to 12. Okay, we're going to start by rearranging. X squared plus 6x plus y squared minus 4y is equal to 12. And then we're going to complete the square for the x's, so that will be plus 6 over 2 squared, and then we have y squared minus 4y plus minus 4 over 2 squared is equal to 12. And we're going to add those same constants on this side to keep our equation balanced. Okie dokie. So then we've got x squared plus 6x, and then 6 over 2 is 3 squared is 9, and then we've got y squared minus 4y, and then minus 4 over 2 is minus 2. You square that, you get positive 4, and on this side it's those same numbers, 12 plus 9 plus 4. So now we factorize that first trinomial, which is x plus 3 squared and that second trinomial, which is y minus 2 squared. And on the right hand side, we've got 12 plus 9 plus 4, which is 25. So that is the equation of the circle in standard form. So what that then tells us is the coordinates of C, the center of the circle, which will be -3 and 2. And as a fun side note, the radius will be the square root of this, which is 5. Right, so I'm going to go ahead and write down the coordinates of C, -3 and 2. Good. And now we said we want to find the coordinates of A, so that we can find the gradient of AC, so that we can find the gradient of this line AD, the tangent. Right, so let's find the coordinates of A and D. So we are going to say, to determine the coordinates of A, we're going to figure out when x is equal to 0, what is the value of y. So that'll be, oh, and we've got it in standard form now, which is quite nice. So you could put it here, you know, but then, yeah, so that term would disappear, that term would disappear. You end up with a quadratic equation, and then you would either factorize or use your quadratic formula to solve it. But in this form, it's quite nice already, because, yeah, I'm struggling to articulate what I want to say, so I'm just going to show you. Right, so that is 9 plus y minus 2 squared is equal to 25, which means that y minus 2 squared is the same as 16. 9 plus 16 is 25. So that means that y minus 2 is equal to plus or minus the square root of 16. So either then y minus 2 is equal to 4, or y minus 2 is equal to -4. So I quite like that, you know, this equation is one that we've managed to solve, like, you see, it's just nice. So then y is equal to 6, or y is equal to -4 plus 2, which is -2. Right, and we can see that A is the higher y-intercept, so that means, therefore, the coordinates of A are 0, 6-ish. Okay, the next question is already peeping through here, so let me move it down. We'll be back, little question. Right, so I'm going to go ahead and fill that in as well. So the coordinates of A are 0, 6, and while we're at it, we might as well fill in the coordinates of B, never know when you need them. So that would be 0 and -2. Right, happiness, happiness. Okay, so now we can work out the gradient of AC. So let's go ahead and do that. So, whoa, the gradient of AC, so remember we said C is -3 and 2A is 0 and 6. Just gonna double check that. Yep. Right, so then the gradient will simply be 6 minus 2 over 0 minus -3, which is 4 over 3. And therefore, so we'll say, since AC is perpendicular to AD, and that is because of tan rad, then that means the gradient of that tangent is equal to negative 3/4. Right, so that is the gradient of this line. So I can then use that to figure out the angle of inclination of AD. So let's go ahead and chat about that. Right, so therefore angle of inclination of AD can be worked out as tan of the angle, we'll just call it, for lack of a better name, we'll call it D, but that's a terrible name. But yes, tan of D is equal to the gradient of AD, which is negative 3/4. The ref angle will be inverse of tan of 3/4, which is, where's my calculator? Okay, gotta find my calculator. Right, shift tan 3/4. So that is about, okay, blah blah blah. Right, and because the tan ratio is actually negative, that means that D is actually 180 degrees minus that. Right, and that is, okay, we're not rounding off yet. I'm going to round off right at the end. So 180 minus that guy. What is happening? Okay, let's do that again. Okay, then 180 minus that guy. Right, so that will be 143,1 blah blah blah. Okay, so what I've now worked out is the size of this angle, right, which is 143,1 blah 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 blah. Okie dokie. Then what we could actually do is, we know that this is a 90. I don't think anyone's going to give you marks for saying that. And then we can work out the size of this angle actually, right? Because here's our triangle, here's the exterior angle. So these two added together should give you that guy. So, you know what? I think it's time for me to make a copy of this picture. It's getting hard to reference it. Okay. Right. So we know that angle AOD is 90 because x-axis is perpendicular to y-axis, and then so therefore the angle BAD will be equal to the 143,1 dot 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 minus 90, and that is because exterior angle of the triangle BAD, what, hey, why am I getting B? OAD. Yes, right, exterior angle of triangle OAD, that looks like that. Okay, which is 53,1 blah 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 degrees. So that's the size of this angle here. Ooh. right? And so the size of this angle over here, which is theta, will be 180 degrees minus this guy, and that's because angles on straight line rot. And what is that? Oh my goodness, everything is so loud. So first we said so 143 minus 90 is 53 comma whatever, and then 180 minus that is 126. Okay, now we need to round off. 126 comma 9 degrees, and I'm going to store that answer. And yeah, that's the size of theta according to ourselves. Okay, and continuing seamlessly, because this totally is not two videos stitched together, we're now looking at question B. A second circle is to be drawn with the following requirements. The circle must be centered at A, over there. It must pass through D on the x-axis. Determine the equation of this circle and show that the two circles touch each other internally. Okay, so let's have a look-see here. So the center of the circle is going to be at A. So that gives us, and that tells us that the equation of the circle is going to be x squared. Whoa. Need to make my pen a bit thicker. Is going to be x squared, right? Or in other words, x minus 0 squared plus y minus 6 squared. And the radius we'll figure out just now. But yeah, that's pretty much x squared plus y minus 6 squared is equal to r squared. And then it's going to pass through D. Right, so maybe something like that. Is that going to become an arc? No, it does not become an arc. Right. Okay, so our circle looks something like that, and of course it, goes all the way there, but yeah, I don't want to get in the way of my question. Hello. Okay, weird. Don't know why it's jiggling the screen instead of erasing. Okay, so the way that we can find r is by finding that distance over there, right? That would be a radius in the circle. And do we know what d is? I don't think we know the coordinates of d. Let's look at the previous question. Yeah, no, we don't know the coordinates of d. However, I think we do know, do we know the equation of AD? Okay, let me just familiarize myself with what we did in the previous question, because the truth is I did this question a couple of days ago, so I've completely forgotten what I did. So in the previous question, we were trying to find the size of this angle. We found the standard equation, well, the equation of the circle in standard form. We found it to be that, which gave us the coordinates of C. Then we found the coordinates of A and B, which is the y-intercepts. Okay, good and well. And then we found the gradient of AC from there. And then that gave us the gradient of AD, because these two are perpendicular to each other. So we got the gradient of AD, perfect. And then we use that to get the angle of inclination. So from there we were just dealing with angles. Okay, so we do not know the coordinates of D. What we do know is the gradient of AD, which we found to be negative 3 over 4. And we also know that AD crosses the y-axis at the coordinate 0, 6. So we do actually know the equation of AD. We have the gradient, we have the y-intercept. So we can use that to find the coordinates. Well, the equation of AD we can then find the coordinates of D, and then we can figure out the length of AD. So let's do all of that. So I'm going to start by moving this guy over here. So the equation of AD is y is equal to, let's just find that gradient again. So the gradient of AD is negative 3 over 4. So it's going to be y is equal to negative 3 over 4x, and the y-intercept of this line is 0, 6, so this will be plus 6. So then, to find the coordinates of D, which we know will be something and 0, because it's on the x-axis, so it will be 0 is equal to minus 3 over 4x plus 6. So that will be, well, let's do this. If I move it to the other side, it will become positive 3 over 4x is equal to 6. And then we divide both sides by 3 over 4, which is the same as timesing by 4 over 3, which will then be 8. Right, and so therefore the coordinates of D, whoa, don't disappear. The coordinates of D are therefore 8 and 0. Right, and so we can now find the radius, the length of the radius. Therefore R, which is the same as the length of AD, will be, can use the distance formula, so that will be the difference of the x's squared plus the difference of the y's squared, and I think that's all going to become 10, because 6, 8, 10 is a Pythagorean triple, but let's double check. 0 minus 8 squared plus 6 minus 0 squared, and indeed we get 10. Right, and so therefore the equation of the new circle, would be, x squared plus y minus 6 squared is equal to 10 squared, and 10 squared we know is just 100. Right, then we are asked to show that the two circles, so this circle and this circle, touch each other internally. So it's not actually a situation like this that I've drawn where it's cutting it twice. What they're saying is that it's going to actually be a circle that goes through D, and then it's going to kind of do that. So it's going to touch this circle like that, just once, and yeah, specifically internally. Okay, I need to take a bite of my lunch while I think about this. Okay, so how I instinctively think of doing that is solving simultaneously this and this, ensuring that there's just one point of intersection. That'll be the one way. Another way, let's think about this, would be I don't know another way. So if I can find yeah, no, I feel like I'm just gonna do it my way. The other way I was thinking was maybe if I can find the coordinates of this point. So if I complete this diameter, I can find the coordinates of this point, the other end of the diameter, using the midpoint formula, and then show that that point does lie on this circle. I mean, that doesn't prove that it's the only point of intersection. It proves that it's a point of intersection. I guess logically you can just kind of see that there wouldn't be another point of intersection because this circle is smaller. Its radius is 5, right, which we found from finding the standard equation for this. So we know that it is a smaller circle than this circle. So kind of, using visual logic, you can see that that would be the only point of intersection between the two of them. But yeah, I don't know if that's a sufficient argument. So I'm going to do it the very long way and solve simultaneously. So we've got our first equation is this guy. X squared plus y squared. I'm sure I could get them both into, no I can't. Plus 6x minus 4y is equal to 12. Okay, so that's my first equation. And then my second equation is x squared plus y minus 6 squared is equal to 100. Okay, so I'm just going to start out by expanding what's everything that's in number 2. So that will be x squared plus y squared minus 6y minus 6y, which is minus 12y, plus 36 is equal to 100. Okay, and remember the trick is to isolate x squared plus y squared so that we can get rid of the quadratic terms and just be left with the linear terms. So if we use number 1, that would be x squared plus y squared is equal to 12 minus 6x minus 4y, or plus 4y, sorry. And from number 2, using the expanded form, we have x squared plus y squared is equal to 100 plus 12y minus 36, right? So I've just moved both of these guys over, and that would be 64 plus 12y, right? So this therefore means that 12 minus 6x plus 4y is equal to 64 plus 12y. right? So then I can express the one variable in terms of the other and then put it into either one of these two. I'm going to express x in terms of the y's. So I'm going to get, so this one, I just need to isolate this term. So I need to minus 12 on both sides and minus 4y on both sides. So then I've got minus 6x is equal to 52 plus 8y. And then I divide through by negative 6. So then I've got x is equal to negative 52 over 6 becomes 26 over 3. And this one would be minus 4 over 3y. Okay, so I'm going to make that my equation number 3. So then I'm going to take that equation number 3 and I'm going to put it in here. So okay, what is that? Right. So sub 3 into equation number 2. So I'm going to replace my x. I should have taken that plus with it. I'm going to replace my x with this new expression that I found for x. Right. So let us square all of that. So so we're gonna have negative, negative 26 over, all right, negative 26 over 3, oh dear. Okay. Oh. Okay, so that is 676 over 9. And then we're going to have minus 26 over 3 times minus 4 over 3. So that will be plus 104 over 9y, and then the same thing again. And then the last one will be minus 4 over 3y times minus 4 over 3y, so that will be plus 16 over 9y squared. And then we've got y times y minus 6y minus 6y, so that will be minus 12y, and then minus 6 times minus 6 will be positive 36, and all of that is equal to 100, right? So let's add up our like terms. You see I've lined them up nicely for us. So we've got 676 over 9 plus 36, which is 1000 over 9, and then we've got 104 over 9y plus 104 over 9y minus 12y, so that will be 100 over 9y, and then this last one will be 16 over 9 y squared plus 1y squared, which is 25 over 9 y squared, all equal to 100, right? And this is now a quadratic equation, so I'm going to get everything onto one side. So 25 over 9y squared plus 100 over 9y plus 1000 over 9 minus 100 is equal to 0.
So that is 25 over 9 y squared plus 100 over 9. And then here we've got, oopsie, 1000 over 9 minus 100, which is 100 over 9 is equal to 0. Can times through by 9 to get rid of, oh, this was meant to be 100 over 9y, sorry. So this will be 100y, and then this is 100, and that just remains 0. And then we can divide through by 25. Right? So this is y squared plus 4y plus 4. Nice little trinomial that we can factorize as y plus 2 squared is equal to 0. So y is actually just one solution, which is what we expected. Like, sometimes we get so caught up in the algebra, we forget what we're solving. Remember that we are solving where do these two circles intersect, and we are indeed expecting that they're going to only intersect once. And we've just found out that they're going to intersect where y is equal to negative 2, right? And to find the x coordinate, we would say, where's that expression? This guy over here. Whoa. Okay, we replace our y with negative 2. So let's go ahead and calculate that. Which is negative 6. Whoa. Right. And so therefore, the two circles only intersect at negative 6, negative 2. And I mean, yeah, I'm happier with that as a proof. Let's see what the memo has to say. So we're going to start on question A. Sorry, I'm looking for the memo. Very professional. 2025 IEB May paper 2. Question 12. Oh, no, that's not what I'm looking for. I'm looking for the memo. So first up we have completing the square, which is what we did. And so we got the center of the circle. And then next up, we had, I think this is us, using the equation of the circle to figure out the coordinates of A. So finding the y-intercepts of the circle. Good. So then we find that the coordinates of A are 0, 6. And then we found the gradient of AC, perfect, which then gives us the gradient of AD as negative 3 over 4. Then from there, we found tan of ADO is equal to negative 3 over 4. That's not true. It's tan of that angle, not tan of this angle. It's tan of this angle. Yeah, okay, but by hook or by crook, we finally get this. They get that angle instead of this one. Fine, whatever. And then they find that angle by adding these two together. exterior angle of this triangle. So yeah, similar approach. Good and well, fine. Then from there, for this second question, they find the coordinates of D, they find them to be 8, 0, and then that gives us, yeah, the equation of the circle to be what we found, the way that we found it. And then they say to touch internally, the distance between centers must be the difference of the radii. To touch internally, the distance between centers must be the difference of the radii. So if you have the two circles and you minus this radius, well, this radius from this radius, what? To touch internally, the distance, also you work out the distance between these two, and then we find that we know that that distance is 5 because it's the radius of the smaller circle. And we also know that the difference between the big radius and the small radius is also 5. So that apparently proves that they touch internally. I don't know. I don't have the brain power right now to make sense of that, but that is, a perfectly valid way, according to the memo, that you could have also justified that these two circles touch internally. We got an excuse to solve simultaneously and show it that way. So yeah, to be fair, the way that we've done it shows that they intersect once. So as for whether they're intersecting once and this circle is inside or it's outside, I think maybe we just need one more step to kind of prove that it's internal. And that would be just visually, the center of the circle is here, the point of intersection is here, so it's an internal touch, not an external touch. Whereas if the center of the circle was out here, then it would be an external touch. I don't know how you explain that, but yeah, I don't even know if it's important to explain that. But that's all I can give. That is all I can give to this question. Let us call it a day. Thank you for coming along for the ride, and catch you another time for another ramble.